Yeah, so the major problem in multiple slit analysis was that I was not able to figure out the fact that we use same direction cosines of the point P in the observer plane to do this stuff, right? If these are the slits, some randomly placed slits, rectangular ones, okay, then yeah, sorry, this is not good. This should be here, and yeah, this is the observer plane. This will be the z-axis, this will be the x-axis, this will be the y-axis, this is x, this is y, this is eta. Cool. So there is a point P here such that it has some direction cosines associated with it, right? Take this color such that I connect it to this. So this is one triangle over here, and this is also one triangle over here. This is x, this is y, this is r prime. Okay, so yeah, what basically we need to do is we need to sum the fields due to sum the fields due to all the slits in the plane, in the xi eta plane, right? So microphone is on. Cool. Sum the fields due to all the slits in xi eta plane, that is all the light entering here, basically the field entering here, resulting in a field at P. How do you calculate that? It is simply, not simply per se, C times integral over aperture 1, slit 1 plus slit 2 plus slit 3 plus slit 4 plus so on to slit n to the power minus IKR, not exactly IKR, L xi plus M eta d xi d eta. Now an important point to note here is that we are considering the integral as this to describe how the integral is. Okay, previously we just had this one slit here and an observer plane here, right? This was P and stuff, direction cosines. You can do that stuff. Okay, cool. Now we integrated all the points in this region, okay, and we got a form of this. You see that for all points there is one thing common is L and M. That's what we physically expected, right? With respect to one slit, we define what is the point on observer plane. Okay, so the direction cosines for all the slits are a standard one with respect to a standard slit. Out of all the slits, we choose one standard slit and then proceed things. It does not really matter, but it should be done so that we can actually analyze it, right? So this is I, this is eta, x and y and z. So what we do here is on the same line we are integrating. The limits were this, right? The limits were this area, but now we extend the limits to here, 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 and all the slits. We expand the limits to this. But how do we do that? Simply, how do we do that? We have to explicitly write xi of this slit from here. This is the origin, right? This is a standard slit and its origin here. We need to write somehow in terms of this. Okay, this is xi comma eta, something, just a general coordinate. We write, to do that we write xi is equals to xi prime plus xi n. You see that what basically we are doing is we define xi prime is equals to a specific or personal plane dimension, personal plane dimension to each slit. Okay, to each slit for that matter. So basically this is the working dimension. This is a transformation factor. See, you just imagine this. This is xi n. Okay. If you think this is xi, you think this as xi prime from here, something like that. You do this. This is xi prime. Okay, let me take another color, perhaps something contrast. Okay, wait, I take red. Yep, bright red. There is here xi, this is xi prime, and the distance between this is xi n, right? Cool. So we define a new coordinate system xi dash and correspondingly eta prime. So that is the thing. So this is the same thing as as previously we were integrating through each part, just like that we integrate through each part, but we express the dimensions of this as conveniently xi prime plus xi n, where xi n is a constant. We remove it out and work with the xi prime. So in the same manner, how we treat the points in a single slit, we treat the same way the points in other slits which are located at a distance xi n from the center from the coordinate system xi. And we get into this and we introduce xi prime. We go xi n and we get this. It's similar to this, right? This is 0, this is 2. If you want to shift to 2, it's like new coordinate system x prime. Now basically what is 2? This is x prime equals to 0, which is x minus 2. X is this point is 2 minus 2, 0, something like that. X prime is x minus 2. That is to say the original coordinates for x dash plus 2. This is eta, this is xi prime, and this is xi n, distance. Something like that, right? Yeah, so we can technically work with single L comma M for whole slit system. That is to say, UP is equals to C times S1 plus S2 plus S3 plus so on. It doesn't really matter, right? IKL. That is to say, UP is equals to C S1 plus integral S2 plus integral S3 so on. It is basically that. UP is equals to C times integral. We transform for each SI. We substitute rather. We express xi, the distance from standard slit or plane or coordinate system xi, the distance from standard slit or plane or coordinate system, the standard coordinate system, which is xi. We express xi as xi plus psi n as xi I, something like that, for all I less than equal to n greater than 0. Okay, I belongs to Z. So we clearly see that xi n terms all are constant, so they just come out, right? And xi1 is 0. That is to note here. We have a thing here. Okay, in our system we have a slit here, the origin, or we are considering the first slit as the standard one, as simple as that. Then it becomes, so it doesn't have any, so here xi becomes xi prime plus 0. So nothing, the integral, the main point to observe is the integral of ik xi prime is common for all things. So what do we get? We get this form, 1 plus e power minus ik l n. Okay. Wait, summation e power minus ik l l psi plus m eta 1 times integral over, if they are equal apertures, so xi prime is specific to their slits, तो identical limits होंगे if they are identical slits. So through an aperture, a general aperture characteristic, we write this. Yep. We write this thing. Okay. And this is the most important form of multiple slit analysis. So the multiple slit analysis takes the form This is the final form of multiple slit characteristic, multiple slit diffraction characteristic.